Alright, so in this particular problem, we have a barge that is pulled by two tugboats. The resultant of the forces exerted by the tugboats is a 5,000 pound force directed along the x-axis of the barge. So essentially it's telling us the barge is going to be moving rightward, okay? And it says here, determine the tension in newtons in each of the ropes if alpha is 45 degrees. So the top angle is 30 degrees, and then here it says alpha is 45 degrees, so the bottom angle is 45 degrees. So even though it's not labeled in the diagram, both the angles are given to you, 30 and 45 degrees. But it's important to note here that it says determine the tension in newtons, while the force here in the diagram or in the statement is given as pounds. So 5,000 pounds of force. So the first thing you should do is convert. Okay, so convert 5,000 pounds to newtons. The conversion ratio or conversion factor between pounds and newton is for every 1 pound, there's 4.448 newtons. Okay, so if we do that, the pounds unit will cancel out, and that'll leave us with about 22,240 newtons. All right, so now that we have the force in newtons, let's go and crack this out. It wants us to find the tension in each of the rope. So rope 1 and rope 2. Okay, so the first thing I like to do is draw out all my components. Here is FAX. So you can call it F1X if you like. Here I'm just going to use the tugboat A. So my subscript is for tugboat A in the X direction. And I'm also going to draw the vertical component for tugboat A in the Y direction. So you notice here FAX is going to point to the right. FAY is going to point up because the tugboat A is pulling up and to the right in the northeast direction. For tugboat C, however, in the diagram here, this is called tugboat C. The force that is pulling is in the southeast direction, so it would have to go down and to the right. So my components for tugboat C is going to be FCX, which is also pointing to the right. However, FCY is going to be pointing down because this vector, once again, tension or the rope in tugboat C, which is called 2, is pointing southeast. South would be implying down, and east would be going to the right. All right, now that we have these things drawn, let's go ahead and set up the physics for this. All right, so in order to find the tension in each of the string, it's important to sort out your information. Here I have my X and Y chart. I know that the net force in the X direction is the sum of AX plus CX. So here in this diagram, tugboat A has an X component, tugboat C has an X component. Both of those are pointing to the right, so I'm going to add them just like normal. However, what I don't know is I don't know FAX, okay? And I don't know what FCX is. But from the diagram, I can set up the geometry for this. According to this particular top triangle, if you can watch my cursor, this is going to the right, up, and that makes a right triangle. The cosine of 30 degrees, by definition, is adjacent over hypotenuse. Here, your adjacent is FAX, and then your hypotenuse, even though I didn't label it here in the diagram, that would just be FA, right? The force of tugboat A. So there's my geometry. Well, to solve for FAX, I'm going to go ahead and move FA to the left side of the equal sign, or you can multiply both sides. That'll give you FA's cosine 30 degrees. And then if we want, excuse me, we can simplify cosine of 30 in our calculator. That'll give you 0.866 and times f of a. So therefore, we have an expression for f of ax in terms of fa. Because we need FAX, right? We don't know what FAX is, but we can figure it out in terms of FA. We don't know what FCX is, but we can use the same strategy and go ahead and utilize the bottom right triangle. So watch my cursor. I'm going to go right. I'm going to go down. And the angle here is given 45 degrees. Therefore, FCX is also the adjacent side, but it's adjacent to 45 degrees. So I'm going to set up here cosine of 45 degrees as adjacent, which is FCX, over the hypotenuse, which is FC. So FC, watch my cursor, is going to be from the barge all the way down to tugboat C. So as you draw that vector, that is f of C. Once again, I didn't label it for you, but hopefully by now you've seen the other videos that you should be able to draw this stuff out. Okay. To get f of C by itself, multiply f of C x by itself, multiply both sides by f of C. So we now have an expression for FCX. FCX is FC cosine of 45 degrees. Therefore, cosine of 45 on your calculator should be about 0.707. And then don't forget the f of c in the front there. I just rewrote it just so that I can keep the coefficient in the front. Okay. Now we have an expression for fax and fcx. We can substitute in for the statement. Well, I know the net force along the x direction is 22,240 because we converted 5,000 pounds to 22,440 newtons. And it said so because it says the 5,000 pound is directed along the axis of the barge. The axis of the barge in this case would be along the x-axis because it's implying that the barge is moving to the right. Okay. But you notice here in the statement, we have two unknowns. We have an fa and an f of c. It's impossible to solve one function with two unknowns. So right away, I think that indicates that we need to utilize the information in the y direction. Well, let's set up the net force in the y direction. In the y direction, you have two vector components, fay pointing up, fcy pointing down. So once again, I've already introduced my negative sign here, so I can go ahead and substitute it in. I don't know what fay is, I don't know what fcy is, but I can use the information given in the problem, and that is sine of 30, which is the top right triangle, is opposite over hypotenuse. So it'd be fay, which is my opposite leg, over fa, which is my hypotenuse, and that's what I have here. Utilizing the same strategy, we can solve for fay by multiplying both sides by fa. So you have sine of 30 times fa, or fa times sine of 30. But sine of 30 is just 1/2 or 0.5, so I want to simplify that to 0.5 fa. All right. Now to find fcy, once again in this statement here, we have fay minus fcy. I don't know what fcy is, but you can do one of the two things. The bottom right triangle is 45 degrees. Well, for any time you have a right triangle with 45 degrees, its horizontal and vertical component must be the same because it's a 45-degree triangle, which implies that the base and the rise has to be the same magnitude. Okay. So I already know the answer for fcy, right? Because it's 45 degrees, fcy must equal to fcx. So therefore, I know that it's also 0.707 fc. However, if you don't think like that, feel free to write this stuff out. You can set up sine of 45, right? Sine of 45 degrees is equal to opposite over hypotenuse. So if we look at this bottom right triangle, this is alpha, which is giving us 45 degrees. Well, if this is 45 degrees, looking opposite from it would be fcy over hypotenuse, which is f of c, this vector there. And therefore, to solve for fcy, we multiply both sides by f of c. But if you know your sine and cosine, sine of 45 is the same as cosine of 45. So therefore, we'll get the same statement, 0.707 f of c. So once again, for this problem, you didn't have to do this if you recognize that because it's 45 degrees, fcx must equal to fcy in magnitude. So you notice here, watch what I'm circling. That right there, fcx is 0.707 fc. fcy is also 0.707 f of c, which makes sense because it's 45 degrees. Okay, let's go and substitute in. Net force in the y direction is 0 because it suggests that the barge is going to be moving in the horizontal direction, which implies that the forces in the y direction must be balanced. Here you only have two components, fay and fcy. So therefore I just say fay minus fcy because fcy is negative because it's pointing down, must equal to 0. So if I do this, I can go ahead and isolate for one of these fa or fc. I've chosen here to isolate for f of c because I want to get rid of this negative sign. So I want to move the negative 0.707 fc to the left side equal sign, which makes it positive. So here, like I said, you can solve for f of c or f of a first. It doesn't really matter. I'm just going to go ahead and solve for f of c since f of c is on the left side of the equal sign. You can do whatever you want. So to get f of c by itself, I can simply divide both sides by 0.707. That's what it looks like. Okay. Well, 0.5 divided by 0.707 on your calculator will give you the same thing, 0.707. But it'd be 0.707 fa. So therefore, I know that f of c is 0.707 fa. Therefore, I can substitute in for f of c in the statement. So I go back to the left side here. I stop because I have two unknowns. I have an fa and an f of c. But using the information in the y direction, I can get rid of one of the variables, fa or fc. I personally have just chosen to get rid of f of c first. You could get rid of f of a first if you like. Okay, the answer will still be the same. So therefore, in the next line here, I've kept everything the same except for f of c. wherever f of c is, I substitute it in for what it's equal to. Fc is 0.707 Fa, so I replace it with the parentheses 0.707 Fa. So you notice here now the only variable unknown in this third line on the xi is Fa. So we can just combine like terms. So I'm just going to simplify. 0.707 times 0.707 will give us about 0.5. Okay. Now combining like terms, 0.866 plus 0.5 Fa will give us a value of 1.366 Fa. To solve for Fa, you would have to divide both sides by 1.366. So if you punch it in your calculator, 22,246 divided by 1.366, you will get a value of about 16,281 newtons. That would be our answer for Fa. But it wants the tension in each rope, right? Therefore, once you know Fa, we can go back to one of these functions on the right side. We know that f of c is 0.707 times Fa. Well, we just found Fa. The fact that we just found Fa, we can just carry this statement down and just substitute in Fa. Wherever Fa is, we can just use the answer we just calculated, which is 16,281 newtons. And then calculator work time, that will give us f of c is equal to 11,514 newtons. And that's kind of it. You just have to do a little plug and chug. You know, you end up with a system of equations here with multiple unknowns. Get rid of one of the unknowns, plug it in, and voila, you'll be done. That's the big picture here. Okay. All right. Stay nerdy. Good luck.